What's up, young mathematicians? Thank you for stopping by here at Tau2Pi. I am Caesar the tutor, and today we're going to find the domain of a function from its equation. Remember, in general, it is a lot easier to find the domain of a function than the range. It is a lot easier to figure out which inputs we need to exclude rather than try to figure out, just from looking at an equation, what the equation is going to return after I give it an input. Okay? Some equations have freebies. For example, if you know it's a polynomial, you're going to know that the domain is all real numbers. And finally, if you have the graph of the equation available, it is much easier to tell the domain and the range from the graph. So, if you know the shapes of these graphs, it makes it a lot easier to visualize how far left, how far right is going, and if there are any restrictions that should be noted, such as asymptotes or weird starts. So that's why it's very important for you to be familiar with the graphs of basic functions. So refer back to the other video where I show the shapes of the basic graphs, because all the graphs that you're going to be working with in Algebra 1 and Algebra 2, or the majority of them, are going to come from those graphs. They're going to be some type of transformation of those basic graphs. And if you know their basic shapes, then it becomes very easy to figure out their domain and their range. So now let's go ahead and take a look at a few examples and see how we're going to figure it out just by them giving us an equation. Now let's take a look at a few examples of finding the domain of a function given the actual equation. The first one is f of x equals 2x squared minus 1/2 x plus 2. First thing you should notice is this is a polynomial. So I'm going to put it right here, polynomial. And we all know that polynomials have domain all real numbers. So right away, I'm going to say domain, and from negative infinity to positive infinity, and I'm done with that problem. Let's take a look at g of x. G of x equals the square root of 3x minus 1. Now, we know that we cannot have a negative number inside the square root or any even root, so we have to find the restrictions to this domain. Now, we could also just set it greater than or equal to 0 and find the domain that way, and that's what we're going to do. So let's take the entire expression inside the square root, and we're just going to say 3x minus 1 has to be greater than or equal to 0. Because we can take the square root of 0, so it stands to reason that it can be 0. And from here, we just solve for x. We add 1 to both sides. We get 3x is greater than or equal to 1. Finally, we divide both sides by 3. And we get that x is greater than or equal to 1/3. Now, there you go. That is our domain. And we're going to write it like this. Domain. Well, we know it has to start at 1/3, can be equal to 1/3, and it goes all the way to positive infinity. So we're going to include 1/3 and go all the way to positive infinity. Now let's take a look at h of x. H of x equals 1 over x minus 5. Now here, our restriction is that we cannot divide by 0. So therefore, we're going to find the values that make this denominator 0, and we're simply going to exclude them or kick them out of the domain. So let's go ahead and do that. We're going to say x minus 5 is equal to 0, and we're simply going to add 5 to both sides, and we get x equals 5. So now we know that whenever x equals 5, we get this 1 over 0 division, and that's pretty much the only restriction to this domain. So sometimes we're lazy and we write domain and we say all x except x equals 5. And that's, that's a lazy way of writing it. And so we're going to write it in interval notation now. In interval notation, we know that we can use everything to the left of 5, everything to the right of 5. So we're going to say, we're going to start at negative infinity. We're going to go all the way to 5. Now we're not going to include negative infinity. We're not going to include 5. And then we're going to skip 5. And we're going to go all the way to positive infinity. And so that is what our domain would look like. Moving on with r of x, we can see that this is a little more complicated version of this one. You still have something in the denominator, but now it's in the second degree. So r of x equals 1 over x squared minus x minus 12. The first thing you want to do with a function like this is to factor it. So let's go ahead and factor it. It will equal 1 over, and we know we have two factors here. Now, how do we factor polynomials, especially quadratics? Well, all we have to do here is find two numbers that multiply to negative 12 that add up to negative 1. So we know that the first ones are going to be x and x. And then 3 times 4 is 12. And to make it negative, we need one negative. So negative 4, positive 3. And there we have it, our factored denominator. Now we can go ahead and from here set it equal to 0 and do all that. But of course, we already know. We can see that a positive 4 is going to make it 0 and a negative 3 is going to make it 0. So we can just go ahead and say x cannot be 4 and x cannot be negative 3. Now, of course, there is a way of writing this in interval notation. We already know that we have to exclude the negative 3. So much like here, we're going to skip it. We're going to jump it. And then we're going to have to create another one. So in a number line, this is what it looks like. In a number line, you're saying, well, my value could be anything on this side. And that would not make it 0. But if I plug in a negative 3, I get a 0. So I'm going to skip the negative 3. And I'm going to go all the way to 4. Now, I know 4 is going to make it the denominator 0 again, so I'm not going to plot the 4, but I can have any number here. And we can even verify. If you plug in 0 here, you get 0 minus 12, so you get negative 112, so we're good. But 4 cannot be in there, and then we can have everything after that. And to write this in interval notation, we're simply going to say, we're going to go from negative infinity all the way to negative 3. So we're not including that. We're not going to include negative 3. Then we're going to union. We have to add this piece here. So we're going to say, well, now we're going to go from negative 3 all the way to 4 without including either negative 3 or 4. And then we're going to union again. And we're going to have this starting from 4 and going all the way to infinity. And this is how you would write the domain of this function. That is all for today. I hope you learned something. If you liked the video, please click like. If you want to see more content like this, make sure to hit the subscribe button. If you have any questions, comments, concerns, or emotional outbursts, drop them in the comments below. Thank you.